We're going to do a really quick overview on the mean value theorem. So if we have some function x cubed, we want to show that there exists some c such that f prime of c is equal to this equation. So this equation right here is the secant line. Secant line, never heard of that? Well, have you ever seen y2 minus y1 over x2 minus x1? This is equal to m, which is just a slope of a straight line that we've learned how to do in basic geometry. So we're just trying to find that on the derivative function, there exists some point c where the derivative is equal to the secant line on that certain interval. So let's find fb, fa, and then b and a. Well, this is just b, which is the upper bound of the interval, and this is a. And then f of b, which is 1, is equal to 1 cubed, which is 1. And f of negative 1 is just equal to negative 1 cubed, which is negative 1. So we have f of 1 minus f of negative 1 over 1 minus negative 1. So we have 1 basically minus a negative 1, which gives us 2. And then this is also 2, which gives us 1. So our slope is 1. So we want to find some point c where our derivative is equal to 1. So if we take the derivative of f prime of x, we get, or let's make this our second step, f prime of x is equal to 3x squared. And we want to set this equal to 1. So we have x squared is equal to 1/3. So x is equal to plus or minus 1 over radical 3. Or you can also say plus or minus radical 3 over 3. So we have 2 points. So we have c is equal to radical 3 over 3. We have c is equal to negative radical 3 over 3. And both of these have a slope of 1 for both of these, right? So we just proved that there exists some c where our f prime of c, which is these 2 points, is going to equal 1, which is the secant slope, basically the secant line, or the slope of a straight line of this interval. So if we draw this out, we have x cubed, which looks something like similar to this. And at negative 1, we have, or if we draw our number line here, we have at negative 1, negative 1. So we have this first point, and then positive 1, positive 1. We have this point, and so we just had this straight line of a slope of 1. And we just proved that x is basically equal to negative radical 3 over 3, which is some point here that also has the slope of this straight line. So both these points also have slopes. So that's exactly what we just proved for the mean value theorem.